Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video I am going to explain the trigonometric form of the apex of a vector. Consider vector u and let vector OM equals vector u. M and u have the same coordinates, and we know that the z of u is the z of m. Magnitude of u equals also magnitude of vector OM, because these two vectors are equal, then they have the same sign, the same magnitude. The angle between x prime x and OM is also equal to the angle between x prime x and a direction of u. If we elongate the vector u remaining parallel to OM, then these two angles are equal as corresponding angles. ZU equals ZM, and what is ZM in trigonometric form? This is OM cosine alpha plus I sine alpha. This is angle alpha. The angle alpha is the angle between x prime x and OM. It is the same as the angle between x prime x and u. Then Z of u equals magnitude of u into cosine x prime xu plus I sine x prime xu. Example: u minus radical 3 over 1. How to calculate magnitude of u? Magnitude of u, radical x square plus y square. Cosine alpha equal real over modulus. Real part equal how much? Real part minus radical 3 over modulus over 2. Sine alpha imaginary over magnitude or modulus, the same, equals imaginary over 2 equals half. Which angle do we have? Then the angle pi by 6 is an argument. No. Here we have minus. Without minus, pi by 6. With minus in the cosine, so we are in which quadrant? In the second quadrant, so pi minus pi by 6. ZU equals 2 into cosine 5 pi over 6 plus I sine 5 pi over 6. Or we can find directly, we write Z of u equals Zm of m, and since m and u have the same coordinates, so Z of m equals x del m plus Iy of m. Conclusion: Z of vector AB equals magnitude of AB equals AB. Z of B minus ZA is Z of AB. ZB minus Z of A is Z of AB. The magnitude of ZB minus ZA is ZAB equals AB. Length of vector AB. Argument of ZAB equals x prime xAB. Given M of fxz and A of fxza equal minus 1 plus 2i. Find the locus of M if modulus of z plus 1 minus 2i equals 4. So we have to write here modulus of zb minus za. Zb minus za. Here z is z of m, and if we take minus common factor, we get minus 1 plus 2i. This is z of a. Then here we have modulus of zm minus za. Z plus 1 minus 2i equals z minus, so Zm minus Za equals Zam. If we take the modulus of Z1 plus 1 minus 2i is modulus of Zam equals Am. Am equals 4. Given 4. A fixed M variable Am equals 4. The locus of M is the circle of center A and the radius 4. Let be 3 minus 1. Find the locus of M if z plus 1 minus 2i equals z minus 3 plus I. Modulus of Z1, Z plus 1 minus 2i is Z lel AM equals modulus of ZAM equal AM. And here we have, if we take minus common factor, we got Z of B. ZM minus ZB modulus, so BM. AM equals BM. So the locus of M is the perpendicular bisector of segment AB. M is equidistant from A and B, then the locus of M is the perpendicular bisector of segment AB. Problem: in the complex plane referred to a direct orthonormal system, consider the points E, M and M prime of respective affixes I. The affix of E is I, the affix of M is Z, the affix of M prime is Z prime, such that Z prime equals IZ plus 1 plus I. First part. Find the coordinates of M prime if M of coordinates 2 minus I. If M of coordinates 2 minus I, then Z equals 2 minus I. We substitute Z equal 2 minus I and we find Z prime, we get the coordinates of M prime. Z prime equals I into 2 minus I equals 2 plus I. What are the coordinates of M prime? M prime is the affix of Z prime, then M prime is 2, 1. Find the algebraic form of Z prime when Z equal radical 2 into cosine pi by 4 plus I sine pi over 4. Here we have to write first Z in algebraic form. How to write Z in algebraic form? We substitute cosine pi by 4 by radical 2 over 2 and sine pi by 4 by radical 2 over 2. We get 1 plus I. Then we substitute the Z equals 1 plus I in Z prime. We get Z prime equal I into 1 plus I. This is Z, 1 plus I plus 1 plus I. This is I plus I square minus 1 plus 1 plus I. Minus 1 plus 1 cancelled. So I plus I is 2I. Z prime equals 2I. And we can write Z prime in trigonometric form directly. 2I is equals 2 into cosine pi by 2 plus I sine pi by 2. Part 3. Determine the modulus and the argument of Z if Z prime equals 1 plus radical 3 plus 2I. Here we have to substitute Z prime 1 plus radical 3 plus 2I and we have to write the trigonometric form of Z. Substitute Z prime. 1 plus radical 3 plus 2I equal IZ plus 1 plus I. Z equals, here 1 cancelled, I to the other side, so we still have 2I minus I equals I, radical 3 plus I over I, Z equals radical 3 plus I over I. We multiply by the conjugate, so we get 1 minus radical 3. How to write how to calculate the modulus and an argument? Modulus equals radical real square plus imaginary square equals radical 4 equals 2. Angle cosine alpha equal real Z over modulus Z equal half. Sine alpha equals minus radical 3 over 2. We are in which quadrant? In the fourth quadrant. Without minus, the angle is pi by 3. In the fourth quadrant, so minus pi by 3. Determine the value of Z for which the points M and M prime are compounded. They have the same, M and M prime, they have the same affix. We write Z prime equals Z. Z equal, since Z prime equals Z, Z equal IZ plus 1 plus I. How to find Z? Take IZ to the other side. We get Z minus IZ. Z common factor 1 minus I, so Z minus IZ. Z common factor 1 minus I equal 1 plus I. Z equal 1 plus I over 1 minus I. We multiply by the conjugate, we get I. Then Z equals I. In case where Z equal I, Z prime equals the same, equals I, and the points M and M prime are confounded. Show that Z prime minus I equal I into Z minus I. Z prime minus I, substitute Z prime. Z prime minus I Substitute z prime equal iz plus 1 plus I minus I cancelled. Here we have 1 and 1 can be written as I square minus I square, because I square equal minus 1 minus I square. Here iz minus I square. Take I common factor, we got I into z minus 1. Deduce that when M moves on the circle of center E and radius 3, the point E of coordinates 0, 1. This is the point of affix I, E, at the beginning of that question. Okay, what does it mean? What does it mean M moves on the circle of center E and radius 3? It means that E M equals 3. So Z M minus Z E equal 3. It means we have modulus Z minus I equal 3. Modulus Z minus I equal 3. We have EM equal 3. ZEM modulus ZEM equal 3. So modulus of ZM minus ZE equal 3. Z lal M هي Z. Z lal E equals I. So we have modulus Z minus I equal 3. Now we go to M prime. Z prime minus I. Modulus of Z prime minus I equal modulus of I times modulus of Z minus I. Here Z prime minus I is the product of two complex numbers. The modulus of the product is modulus times modulus. So modulus of I times modulus of Z minus I. Modulus of I is 1. Modulus of Z minus I equals 3. Then Z prime minus I equals how much? Modulus of Z prime minus I equals 3. So here we have E M prime. E M prime equals 3. Here Z M prime minus Z E. This the modulus is E M prime. E M prime equals 3. E M prime equals 3. The locus of M prime is the circle of center E and radius 3. Same circle. Same circle. Thanks for following and good luck.